Hello everyone and welcome. Today I would like to talk about search insert position. We'll be using binary search algorithm. This is a comparison how much time we can save by using binary search algorithm. This question provides you a sorted array of distinct integers and a target value. Asks you to return the index if the target is found. If not, return the index where you would be if you were inserted in order. Importantly, it asks you to use an algorithm with O log n runtime complexity, which means the binary search algorithm. On binary search algorithm, I have made two other videos, the binary search and first batch version. Please feel free to look up these two other videos if you are interested. Now, I will walk you through the binary search algorithm for this question. Although the solution here may look simple, it is important to understand the solution thoroughly. Here, we know that the index for target must be an integer within the inclusive range between 0 and the length of nums array. Know that we want to allow the situation where a target is larger than all the numbers in the nums array. Therefore, right index is initialized to be the length of the nums array. To figure out what an index is to insert the target, and we also know that index must be within this range between left and right. Therefore, we make a guess using the floor midpoint between left and right, the floor division here. If nums mid is the target, then we simply return mid as the answer. Otherwise, we adjust left and right indices toward the target index until we hit the target or until left and right indices converge. Most importantly, when nums mid is less than target, we will have the left pointer point to mid plus 1. This is because the position to insert the target must be greater than mid, and the lowest number that's greater than mid is mid plus 1. On the other hand, when target is less than nums mid, we'll have right index point to mid. The reason is because the position to insert target could still be the same as mid, and we cannot go below mid. You may be wondering, what if the target is not one of the existing numbers in the nums array? In that case, we'll eventually boil down to the following situation. Left equals to mid and right equals to left plus 1. In this situation, there are three different follow-up situations. But regardless of which follow-up situation, at the next iteration, right will converge to left or left will converge to right. Thus, if the target is not in the nums array, when left and right converge, that will be the answer, and we will return the answer. In summary, there are two ways to return the answer. First, when nums mid is the target. Second, when left equals to right. One interesting question is, what if we do not return mid when nums mid is the target? In that case, right will become mid first, and left will increase gradually until they converge. In that situation, we will still be able to return mid through left, but just a little bit slower. However, the code is a lot more concise. It is worth noting that this concise version of the code above is also the implementation in the bisection library, as shown here. With the background introduced, now let's write the code and test it. So first of all, we initialize left and right to be 0 and the length of nums array, and while left is less than right, we have the mid equals to left plus right divided by 2, but this is a floor division. And we want to see if nums mid is the same as target or not. If it's the same, we return mid as it. Else, if the nums mid is less than the target, then we know left should be mid plus 1. And finally, if nums mid is larger than the target, then we know that right should be mid. And finally, we will return left when left and right converge. So now let's test this code. We submit, it's pending, and done. It's pretty good. Finally, we'll analyze the code for complexity. Since we use the binary search algorithm, the time complexity will be O log base 2 of n. Since we use the binary search algorithm. And for space complexity, it will be O1 since we use only constant space variables here. And that's all for this video. Hope you find this video to be useful. Please subscribe for more videos. And hope to see you next time soon. Goodbye.